So this is a joint program of the University of Pécs, South Hungary, and the University of Osijek, Croatia. And the subject was to test more than 50 buildings, houses in the border region in both countries. The scientific target was the gather information of the airtightness and air change rate of the buildings and houses in the region, various types, use, and age. Then the collected data is used to estimate the energy and thermal comforts, as well as air quality consequence of these typical air change rates, ventilation, airflow, and air velocity in the rooms. Another scientific target was to find correlation between the air change rate measured at 50 Pascal pressure difference and that of during normal conditions. So you might know the 50 Pascal pressure compared to the ambient is high enough to eliminate the effect of the ambient conditions, apart of course from strong wind, but it's not the air change occurs during normal conditions. So we also targeted to measure air change rate during normal conditions and compare it with the 50 Pascal pressure difference tests. When carrying the airtightness test, we tested in both A-type test, that air change rate when the vents are not sealed, and we performed also B-type test when this is the airtightness test when the vents are sealed. And here you can see some results of one example. In one case, at 50 Pascal, the airflow is nearly 700 cubic meter per hour, and the other case in sealed vents, the air change, the flow at 50 Pascal, it is 500 cubic meter per hour. When measuring spontaneous air change rate with blower door, the problem is that it affects the actual measured phenomena. So if we want to take a measurement that is not affecting the actual phenomena, the air change rate, we need to find another method, and we selected the tracer gas method to test the natural ventilation rate. Of course, this ventilation is highly dependent upon the temperature difference and the wind speed, so it's not suitable for classification purposes. We selected the concentration decay test method using SF6 tracer gas. We release a small quantity of tracer gas in the air and measuring the concentration decay. Since this sulfur hexafluoride is 5 times heavier than air, a proper mixing fan process should be applied during the test to ensure that the concentration is the same at all points in the rooms. So the air change rate can be calculated from the tracer gas test, the natural logarithmic of concentration 1, and the natural minus the natural logarithmic of the concentration at the second point divided by the test period. When plotting this logarithmic change against against linear scale, a good mixing is represented by a straight line. If the line is not a straight line, then the mixing was not good enough. We found quite good correlation between the various test methods. So we can assume that our conclusions will be right. This chart, this table shows some results in Hungary. these homes measured as a whole. And we also carried out on the type of test when we measured buildings or houses by a representative room. So these are various typical construction, brick houses, there were some concrete block apartments, detached house, semi-detached house, two lightweight constructions, and you can see the results, the sequence of the construction time, and if in case there were refurbishments. And the two red bars show the air change rates in case Airtightness at 50 Pascal and 4 Pascal temperature pressure difference. In this case, there were open fire in the building, so the high air change rate is due to the open fire. When plotting these results against the time scale, there's a clear correlation how the air change rate is lower as time goes forward. But of course, there are quite different individual houses, individual results. For instance, in this case, it is a refurbished house built originally in 1980, but it was refurbished in the recent years. And there are some houses are better than the average, others are, of course, worse. This is another table from the Hungarian side when we performed the B-type test, the air permeability test with sealed vents, and of course the air change rate are much lower than before. Here are all the results of tests in Croatia, 58 altogether. It did a sequence of construction time, and most of these old houses were already refurbished, and the air leakage results at N50 and the average values at N50. The second, and the worst is this house, nearly 20 air change rate, and the best was this house, a refurbished one at 0.76. The second table of the Croatian results, the newer houses, of course, are not refurbished yet, but the older ones, mostly refurbished. And here in this bar, you can see the average change rate. And this chart shows the Croatian results. Interestingly enough, there is a high peak in this period. And also, it was surprising that the newer houses are worse than the houses in 10 years ago, was built in 10 years ago. But it's due to the small number of cases. It's significant, not statistically, not really relevant. So the conclusions are that field tests were carried out in Hungary and Croatia, examining airtightness and natural air change rate, and of course some comfort tests are not reported yet. Correlation found between blower door test and tracer gas test. We worked out a method to calculate the air change rate from blower door test series, and it was also an objective to establish cooperation with the research team of EACI, Croatia, and Pécs University in Hungary. Thank you very much for your kind attention, and I'd like to express my acknowledgement to colleagues in University of EACI, Croatia. Thank you.